Welcome to Lecture 13. This is about respiratory pathogens and the diseases they cause. It's split into 4 big sections again. In this case, we're looking first at the upper respiratory tract or the upper respiratory system, and that's split into bacterial diseases and viral diseases. And then we look at the lower respiratory tract, bacterial and then viral diseases. So we start at the upper respiratory tract, and these are the types of diseases we typically would see. And so all the diseases we look at would fall into one of these, where we're seeing infections or at least inflammation of the different parts of the upper respiratory tract. Here we have a mid-sagittal section of a head, and what we can see is a lot of the respiratory tract. Up here we have a nasal cavity and the pharynx, and then the epiglottis and the larynx, and all those other things. And so upper respiratory tract infections, many of them will infect the nasal cavity, and that can lead to the nasal discharge we're accustomed to. And any infections of the tonsils would lead to soreness in the pharynx. And then much more severe infections might be infecting the epiglottis. And whenever we have swelling of the epiglottis, that can potentially cut off the airway, so that could be a much more serious outcome. The larynx itself has cartilage that mostly keeps it open, and the trachea has cartilage that mostly keeps it open. But when those swell, when the soft tissues swell, that can cut off air. So we start with the bacterial diseases, and the first one we go to is back to Streptococcus. So Streptococcus, if you remember, causes skin diseases and other diseases, and there are several groups of Streptococcus bacteria that all do sort of different things. And so we separate them into groups like Group A strep, Group B strep. Group A is the Streptococcus pyogenes, and this is, in some situations, the most dangerous ones. In other situations, Streptococcus pneumoniae, or Group B, is more dangerous because it would cause things like meningitis. But in this case, it causes pharyngitis, or strep throat, or a sore throat. But it's more severe than a sore throat because it can have complications that go beyond pain. So the first kind of pharyngitis we look at is from Streptococcus. This is the strep throat that people are familiar with, and it causes a straightforward inflammation of the pharynx and the tonsils that is very painful. And compared to the common cold or influenza, this is more treatable in that we have an array of antibiotics that work against Streptococcus. Treating this can be a good idea because there are some severe complications that can come from streptococcal pharyngitis. So some signs you could get that would distinguish this from the common cold, or mostly from the common cold, would be that this isn't likely to cause a cough, whereas a cold could irritate all the epithelial cells in your upper respiratory tract, and also the what we would expect from irritation of our nasal cavities, the mucus production. We wouldn't see that as much because this is more confined to the pharynx. So streptococcal pharyngitis can lead to other streptococcal diseases, and these diseases have historically happened in outbreaks where streptococcal pharyngitis would spread in outbreaks, and it was common enough that we would see rare and very dangerous complications. These complications include these two autoimmune diseases. Rheumatic fever, for example, is the one that can lead to heart valve damage that predisposes a person to bacterial endocarditis. Streptococcal toxic shock syndrome is toxic shock syndrome, and that is life-threatening. That's immediately life-threatening. And again, this would depend only on the bacteria releasing a specific toxin that activates the immune system. And we've seen other streptococcal diseases, and it's always a possibility that if the immune system lets the bacteria penetrate tissues and get into the lymphatic system or into the bloodstream, it can go to different parts of the body. It can cause soft tissue infections and potentially meningitis and lots of other diseases. We might associate those more particularly with group A strep or group B strep, but it's a better idea to not think of those as completely separate from each other. They do sort of specialize, but it is possible for either of them to cause the other one's diseases in some cases. So that can be an important thing to think about. Scarlet fever is the most common, and that will still happen. And what happens with that, you can see in one of the curiosity slides at the end of the lecture. Basically, the bacteria causing the pharyngitis release a toxin that causes a red rash, a distinctive deep red rash. And that itself isn't harmful, but it's scary. And when that happens, historically, that's how people knew it was a streptococcal infection that could trigger these things. And so historically, if we're looking back at the 1800s, this led to high mortality rates from streptococcal infections. And scarlet fever was listed as a very common cause of death in children. These days it is not, because these days we can treat it with antibiotic, but also there was a drastic decline in this disease long before antibiotics were invented, and I have never seen information about why this happened. The next disease, diphtheria, this is better known as a severe disease, and we widely vaccinate against this. I'll show you why in a second. It's caused by Corynebacterium diphtheriae, and this will spread as outbreaks through respiratory droplets, not surprisingly. What happens with diphtheria is a membrane forming in the pharynx. So a combination of bacterial damage to the epithelium and the immune system responding to it can lead to this pseudomembrane forming. And this is not something that can be just removed from the throat. This is kind of integrally attached to the epithelium. And in severe cases, this can grow to obstruct the airway. If this grows on the epiglottis, for example, it can completely block off the airway. And so this bacterium doesn't invade the tissues, but the exotoxin, the tracheal toxin is what it's called, it can damage the cells and lead to that membrane forming. So this is another example where the bacteria themselves are harmless, but if they release a certain toxin, that toxin has severe effects on the body. And again, what it can lead to is growths of a pseudomembrane in the trachea and larynx, and that can cut off the airways. And so this was a widely feared fatal disease for children, and now in the U.S. people don't know what it is because we vaccinate so effectively. The various what's the word I'm looking for? Formulations of the vaccine. So Tdap, DTaP, DT, or TD, the more old-fashioned ones that people my age took, DPT, DT, all of these protect us against diphtheria. That was an early goal of modern public health and vaccination. If a person gets diphtheria, that is kind of an emergency, and we can treat the bacteria, but if they've already released the toxin can be doing damage after the bacteria are dead. So that's why we have exotoxin neutralizers. And if all we do is treat the bacteria, that might not be enough. So this is an example where we would kind of have to understand the bacterial infection to be able to respond to it. Okay, in the next video we will look at viral diseases of the upper respiratory system, and we're all very familiar